Hello once again and welcome to my channel. It's Walter here, and today I'll be taking you through paper 11 for Pure Mathematics 1. That's for October and November 2020. So let's get started. Question number 1. Find the set of values of m for which the line with the equation y is equal to mx minus 3 and the curve with the equation y is equal to 2x squared plus 5 do not meet. So right here, we are talking about the intersection or the interaction between a line and a curve. And we know that if a line and a curve do not meet, then the discriminant, that's b squared minus 4ac, should be less than 0. So here, we're going to combine the two equations. And you can see that the first equation is y is equal to 2x squared plus 5. And we're going to say it's equal to the second equation, which is also y is equal to mx minus 3. So I'm going to bring everything to one side. So right here, I'll write 2x squared, and I'll subtract mx from both sides, so that's minus mx. And we already have a 5 here. And I'll add 3 to both sides, and that will be plus 3. So it's all equal to 0. So this means that we have 2x squared minus mx plus 8 is equal to 0. Now for the discriminant, we're saying a is equal to 2, b is equal to minus m, and c, which is the constant, is equal to 8. And therefore, for b squared minus 4ac, we are going to say minus m squared minus 4 of 2 and 8. And we say, since the curve and the line do not meet, this has to be less than 0. So that's m squared minus 4 times 2, that's minus 8. And 8 times 8 is 64. So we have a 64 here, and it's all less than 0. Now for the critical values, we're saying that we can equate m squared minus 64 to 0 to get the critical values here. And this is a difference of two squares. We can say this is m plus 8 and m minus 8. That's equal to 0. Which therefore means that our values of m, by equating both vectors to 0, m should come out as minus 8 or 8. So we now have two critical values. So right now, in order for us to find the values of m which satisfy this inequality, then we will have a sketch of the graph. So this will be the m-axis, and right here we will be having the parabola. It's going to be u-shaped because the coefficient of m squared is positive. So we have this point here and this point here. This should be minus 8 and this should be 8. Now the graph is going to be positive above the axis and negative below the axis. But here we're looking for values such that m squared minus 64 is less than 0, which means negative, right? Which therefore means the graph is negative for values of m between minus 8 and 8. That's where it's below the m-axis. So this therefore means that our solution here should come out as minus 8 is less than m is less than 8. So that's the solution, the set of values of m for which the line and the curve do not meet. Let's go to the next question. Question number 2. The equation of a curve is such that dy by dx is equal to 1 over x minus 3 all squared plus x. It is given that the curve passes through the point 2, 7. Find the equation of the curve. So right here, we have dy by dx being equal to 1 over x minus 3 squared plus x. Now, in order for us to get back to the equation of the curve, what we will need to do is integrate both sides. So this is what I'm going to do, which means that on the left side, if we integrate dy by dx with respect to x, we are going to get y. And on the right side, if we integrate 1 over x minus 3 to the power of 2, which is the same as x minus 3 to the power of minus 2, integrating this, we are going to get x minus 3 to the power of minus 2 plus 1, that's minus 1, all over minus 1. And if we integrate x, we're going to get half x squared, and that's going to be plus c. So this can simplify to, since we have a minus here, a minus 1 here, that's minus, and x minus 3 to the power of minus 1 is like 1 over x minus 3. And that's plus 1 over 2x squared, and that's plus c. So what we have here is now the general solution or the general equation of the curve. But now we need to work out the value of c, and we can use the fact that the curve passes through the point 2, 7. So since it passes through the point 2, 7, it therefore means that when x is 2, y is 7. So I'm going to substitute, in place of y, I'll put a 7, and that's equal to minus 1 over, in place of x, I'll put a 2. So that would be 2 minus 3, and that's plus 1 over 2 of x squared, which will be now 2 squared, and then that's plus c. This is going to give us 7 is equal to, so here we've got 2 minus 3, which is minus 1. So minus 1 over minus 1 gives us a 1. Then half of 2 squared is like half times 4, that's 2. So that's plus 2 plus c. So 7 is equal to 3 plus c, which therefore means that c comes out as 4 after subtracting 3 from both sides. So now that we have the value of the constant c, we can therefore now say the equation of the curve should come out as y is equal to minus 1 over x minus 3 plus half x squared plus 4, and this becomes the answer right here. Let's go down to the next question. That's question number 3. Air is being pumped into a balloon in the shape of a sphere so that its volume is increasing at a constant rate of 50 cubic centimeters per second. Find the rate at which the radius of the balloon is increasing when the radius is 10 centimeters. So let's write down the information given. We've been told that the volume is increasing at a constant rate of 50 cubic centimeters per second. That's dV by dt is equal to 50. We also have information that this is a sphere, and we know that the volume of a sphere is 4 over 3 pi r cubed. And you see, this is a rates of change type of question, and we're also definitely gonna need to find dV by dr. So let's look for it. So let's differentiate v with respect to r, which means that we'll be having the constant 4 over 3 pi, and differentiating r cubed, we get 3r squared. So this here is going to give us 4 pi r squared for dV by dr. Now with this information, we can now find the rate at which the radius of the balloon is increasing, which is dr by dt, and using the chain rule, this is going to be dr by dv times dv by dt. So this is the chain rule that we're going to use. So what is dr by dv? Now we have dv by dr. So dr by dv will be the reciprocal of this. So that will be 1 over 4 pi r squared. And then that's times dv by dt. That's what we have here as 50. So basically, we are saying that dr by dt is 50 over 4 pi r squared. But we've been told that we are looking for the rate at which the radius of the balloon is increasing when the radius is 10. So here we're working with r being equal to 10. So when r is equal to 10, it therefore means dr by dt is going to be 50 over 4 times pi times r squared, which in this case will be 10 squared. That's the same as 50 over 4 times 10 squared, which is 100. That'll be 400 pi. And we can just type this in. So that's 50 over 400 pi. And this gives us 0.00398 to 3 SF. So that's 0.0398. And that's centimeters per second. And that's the answer for us right here. Let us look at question number 4. In the diagram, the lower curve is equation y is equal to cos theta. The upper curve shows the result of applying a combination of transformations to y is equal to cos theta. Find in terms of a cosine function the equation of the upper curve. So we have right here the graph of y is equal to cos theta, and it's being transformed onto the graph above it. Now, when we are considering transformation, there are two sets of transformations to be concerned about. The first set of transformation is the one that affects the vertical aspects of the graph. And here, if we have our original function y is equal to cos theta, which I want to write as y is equal to f of theta, then it has to be transformed in the vertical to a new graph y is equal to a of f theta plus b. A should represent a stretch parallel to the y-axis, and b should represent a translation in the positive y direction by b units. So in this case, the point, if you take a point like a point 1 here, you can see how it is being transformed to a corresponding point on the other graph, which is at 5. So we are saying the point y is equal to 1 is being transformed onto y is equal to 5, which therefore means that a of f of theta, which in this case is 1, plus b is giving us 5. So this translates to a plus b is equal to 5, where a and b are constants to be found. Again, you can see that another point that we can take, which is this point, which is the first lower peak of the graph of cos theta on -1, is being transformed onto the first lower peak of the other graph is here, which has a y value of 1. So we're again saying here the point y is equal to -1 is being transformed onto the point y is equal to 1, which means that a of the point f of theta -1 plus b is giving us a 1, and this is the equation minus a plus b is equal to 1. Now we now have two simultaneous equations which need to be solved, and I'll do this simply by adding equation 1 plus equation 2. If we add equation 1 plus equation 2, that's a plus minus a gives us 0, b plus b gives us 2b, and 5 plus 1 gives us 6. So this therefore means that b is equal to, dividing both sides by 2, b comes out as a 3. And again, we can also find, using any one of the equations, like equation 1, we can say since a plus b is equal to 5, then that's a plus 3, which we got, is equal to 5. And this therefore translates to a being equal to 2 after subtracting 3 from both sides. So we now know what a is and what b is. So we're going to be using this a bit later. Let's now consider the horizontal aspects of the transformation. So for horizontal, we are mainly concerned about the region inside the bracket around theta. The set of transformations, I would want to represent them with constants c and d, like c theta plus d. So this will affect the horizontal aspects of the graph. So let's look at some x points that have been transformed. And let's start with this point here, which has an x coordinate of 0. So this point has been transformed onto this point here, which also has an x value of 0. So we're saying here the point 0 is being transformed onto point 0, which therefore means that c of 0 plus d is giving us 0. And this translates to d is 0. Again, let's look at another set of points. Another set of points can be the first lower peak of the graph of y is equal to cos theta should correspond to the first lower peak of the transformed graph, which is here on 2 pi. So this first lower peak of y is equal to cos theta is on pi. So pi is being transformed onto 2 pi. So let's have that as well. The value x is equal to pi is being transformed onto x is equal to 2 pi, which therefore means c of theta, which is pi, plus d is giving us 2 pi, which is pi c plus d is equal to 2 pi. But we know that d is 0, which therefore means that pi c is equal to 2 pi. And if we divide both sides by pi, we get c coming out as 2. So we now know what c is. So let us now write the transformations. So we have y is equal to a, in this case, is 2. So that's 2 of f of. And inside the bracket, we're going to be having c theta plus d. So we got c to be 2. But since the graph has been widened out, I'll write that factor as 1 over 2. So it's 1 over 2 theta, close bracket, and then it's plus b, and we got b to be 3, so it's plus 3. So eventually, in terms of cos, we write it as y is equal to 2 cos of half theta plus 3. So this becomes the final answer. Question number 5. In the expansion of 2x squared plus a over x all to the power of 6, the coefficients of x to the power 6 and x cubed are equal. So on a, find the value of the non-zero constant a. So here, we are going to consider the general expansion or the general form of the binomial expansion a plus b to the power of n, which comes out as n choose r, a to the n minus r, and b to the power of r. So in our case here, we'll be saying the general form for the terms in the binomial expansion of this should be 6 choose r and 2x squared to the power of 6 minus r and a over x to the power of r. So now we can split this into coefficients and also into x terms. Now for the coefficients, we are going to take the constants only from this. So that will be 6 choose r, and here we take the 2, so that's 2 to the power of 6 minus r, and here we take a, and raised to the power of r, so that's a to the power of r. And for the x terms, I'm going to take only the terms in x, so that will be x squared, and that's raised to the power of 6 minus r. And here we have 1 over x, and it's raised to the power of r. So this can be simplified to x to the power of 2 times 6 minus r, that will be 12 minus 2r, and it's multiplied by 1 over x is x to the power of minus 1, and that power minus 1 multiplies r to get x to the power of minus r. So this comes out as x to the power of, adding the powers, we get 12 minus 3r. So we now have the general form for all the x terms in the binomial expansion and the coefficients in the binomial expansion of 2x squared plus a over x to the power of 6. Now, for the term in x to the power of 6, we can now say x to the power of 12 minus 3r, which is the general x term, is equal to x to the power of 6, which therefore translates to 12 minus 3r being equal to the power 6. We're equating the powers here. So we can solve for r, and r comes out as 2. And now we can say for x to the power of 3, for x cubed, the x term, which is x to the power of 12 minus 3r, should be equal to x to the power 3, which therefore translates to 12 minus 3r being equal to 3. So if we solve for r from this small equation, we get r coming out as 3. So we now know the value of r for the term in x power 6 and the term in x cubed. According to the question, the coefficients of x power 6 and x cubed are equal. So we're saying, since coefficient of x to the power of 6 is equal to coefficient of x cubed, then the coefficient of x power 6 occurs when r is equal to 2. So that's 6 choose 2 here, and that's 2 to the power of 6 minus 2, that's 4, and a to the power of 2, so that's a squared. That's equal to the coefficient of x cubed, which in this case r is 3, so that will be 6 choose 3, and that's 2 to the power of 6 minus 3 is 3, and a to the power of 3. So let's just make use of our calculator here. Let's start with 6 choose 2 times 2 to the power of 4. So that's 6 choose 2, and that's multiplied by 2 to the power of 4, that's 16. And this gives us 240. So we have 240 a squared here. And again, we are going to say 6 choose 3 multiplied by 2 to the power of 3, which is 8. So we get 160. So that's equal to 160 a cubed. So I can now solve for a. And how I'm going to do that is I will divide both sides by 160 a squared. So that means that here on the right side, the 160 and the 160 will cancel. And if we divide a squared into a cubed, we get a to the power of 1. And on the left side, I can divide a squared into a squared, and we get 1. And 240 over 160 is what remains. So that's 240 over 160. Now this can be reduced to 3 over 2, because 80 gets into here 2 times and 80 gets into here 3 times. So it therefore means that a comes out as 3 over 2. And that's the solution to part A of the question. Let's go to part B. Find the coefficient of x power 6 in the expansion of 1 minus x cubed bracket 2x squared plus a over x to the power of 6. So for this one, we are saying to get the coefficient of the term in x power 6, when we expand these two brackets, it means along the way as we expand, 1 is going to multiply the second bracket. And for us to get a term in x power 6, 1 should multiply a term in x to the power 6 minus x cubed. Will also multiply the terms in the binomial expansion. And for us to get a term in x power 6, x cubed must multiply a term in x cubed. So this is what's going to give us a term in x to the power 6, from which we can take the coefficient. Now for the term in x power 6, we are saying it's 1 times the term in x power 6 of this binomial expansion. We had already worked out that for x power 6, r is 2. And when we simplified it, the coefficient came out to be 6 choose 2 to the power 4a squared, which was 240a squared. So that's the coefficient right here. So we have 240a squared, and that will be x to the power of 6. And that's minus x cubed, and the term in x cubed in the binomial expansion, we had gotten the coefficient of x to the power 3 as 6 choose 3 2 cubed a cubed, which then came out to be 160a cubed. So that's what we're going to use here. So that will be minus 160a cubed, and that will be x cubed. So we can simplify this. So on the left side, we have 240 here, 1 times 240, and that's times a squared. A is 3 over 2, so that will be 3 over 2 squared, and that's x to the power of 6. That's minus, and here we're going to have 160, and then that's times a cubed, which is 3 over 2 cubed, and x cubed times x cubed, that's going to give us x to the power of 6. So let's simplify this. So we have 240 times 3 over 2 squared, and this gives us 540. So here we have 540 x to the power of 6, and that's minus, and that's going to be 160 times 3 over 2 to the power of 3, and again it gives us 540 x to the power 6. Now 540 x to the power 6 minus 540 x to the power 6 is going to give us 0. And that's the answer. So the coefficient of x to the power of 6 is just going to come out as a 0. And that's how we do it. Let's move to the next question. Question number 6. The equation of a curve is y is equal to 2 plus square root of 25 minus x squared. Find the coordinates of the point on the curve at which the gradient is 4 over 3. So here we have our equation as y is equal to 2 plus, and I'll write this as 25 minus x squared to the power of a half. So now, since we're talking about gradient, we are going to work out the gradient function. So dy by dx. Differentiating 2, that's a constant, we get 0. And differentiating 25 minus x squared to the power of a half means we bring down the half. Then we differentiate 25 minus x squared, which gives us minus 2x. And then we write down the 25 minus x squared. And then we raise it to the power of a half minus 1, which is minus a half. So this is what we have, which therefore means that dy by dx will come out as half times minus 2x. We get minus x. And here we've got 25 minus x squared to the power of minus a half, which I can write as over 25 minus x squared to raise to the power of a positive power. So this is now the gradient function. So according to the question, they say find the coordinates of the point on the curve at which the gradient is 4/3. So I'm going to equate the gradient function x over 25 minus x squared to the power of a half to the gradient, which is 4/3. And from here, I'm going to square both sides. So I'll square here and I'll square here. So here, squaring, I'll be having x squared over, and if I square here, that will be 25 minus x squared is equal to 4 squared, that's 16, and 3 squared, that's 9. So here I'll cross multiply. So I'll multiply 9 times x squared, that's 9x squared, is equal to 16 times 25 minus x squared, that will be 16 bracket 25 minus x squared. So now I'll be having 9x squared is equal to 16 times 25, that's 400. And 16 times minus x squared, that's minus 16x squared. So if I add 16x squared to both sides, I have 25x squared is equal to 400. And dividing both sides by 25, I get x squared coming out as 16. So if we square root both sides, we get x here, and square root of 16 is plus or minus 4. Now we're coming out with a positive value for x and a negative value. According to the question, they want the coordinates of the point on the curve at which the gradient is 4/3. And I think you can see that 4/3 is a positive value, which means the x value, which will give us a positive value for the gradient, is in this case going to be minus 4. You see how if we substitute minus 4 into the gradient function, the gradient will come out positive. So that means here that I'm going to make use of x being equal to minus 4 instead of plus. So here, if x is equal to minus 4, if I go back to the equation of the curve, I can find the value of y. So we have here this as the equation of the curve. Y will come out as 2 plus the square root of 25 minus 4 squared, which is 2 plus the square root of 25 minus 16, and that's 9. Square root of 9 is 3, so that's 2 plus 3. And this gives us 5. And therefore, the coordinates are going to come out as minus 4 and 5. And that's the answer right here. Question number 7. Show that sine over 1 minus sine theta over 1 plus sine theta is identical to 2 tan squared theta. So right here, we have an identity and we're going to select a side to work with. So let's work with the left-hand side. Now with the left-hand side, I can have a common denominator. So in this case, the common denominator can be 1 minus sine theta bracket 1 plus sine theta. And I'm going to multiply sine theta by 1 plus sine theta. So that would be sine theta bracket 1 plus sine theta. And I'll multiply again minus sine theta times 1 minus sine theta. So that would be minus sine theta bracket 1 minus sine theta. Here, I will simplify the bracket. So sine theta times 1 is sine theta. Sine theta times sine theta, that's sine squared theta. Minus sine theta times 1, that's sine theta. And minus sine theta times minus sine theta, that would be plus sine squared theta. And it's all divided by the denominator here. I'm going to simplify the numerator. So sine theta minus sine theta, this two will give us 0. So we're now left with sine squared theta plus sine squared theta, giving us 2 sine squared theta. And here 1 minus sine theta and 1 plus sine theta comes out from a difference of 2 squares, which is 1 squared minus sine squared theta. So this is what we now have. But we know that 1 minus sine squared theta is actually cos squared theta from the identity. So we can say 2 sine squared theta is equal to 1 minus sine squared theta is cos squared theta. And eventually what we're going to get is sine squared theta over cos squared theta is tan squared theta. So it's 2 tan squared theta, and this becomes the answer. So we have proved the identity because they wanted us to show that it comes out to 2 tan squared theta, and that's what we got. Let's go to part B. Hence solve the equation sine over 1 minus sine theta minus sine theta over 1 plus sine theta is equal to 8. So right here, we know that this trig function is identical to, that's what we were working out in part A, is identical to 2 tan squared theta, the one we got. So in place of it, I'm going to put 2 tan squared theta. So that's equal to 8. And remember, we're solving from 0 to 180 degrees. I'm going to divide both sides by 2 so that we get tan squared theta is equal to 4. And I'm going to square root both sides. And when I do, I'll get tan theta here is equal to plus or minus 2. So therefore, for theta, I'm going to do arctan of 2. So I'll need a calculator for this. Second function tan of 2. And this gives us 63.4 degrees. So that's 63.4 degrees. If you look at the quadrants, we know that tan theta is positive in the first quadrant and in the fourth quadrant where it has the value 180 plus theta. It is negative in the second quadrant where it has a value of 180 minus theta, and also negative in the fourth quadrant where it has a value of 360 minus theta. So now since tan theta is both positive and negative from plus and minus, it means it has a value in all these quadrants. But the ones that we want here are the ones that satisfy the range 0 to 180 degrees. So we're going to take a value from the first quadrant, which we already have here as 63.4. And we're also going to take a value from the second quadrant, which definitely should lie within range. So the other value of theta is going to be 180 degrees minus 63.4 degrees. And this gives us 116.6 degrees. So therefore, the values of theta are 63.4 degrees and 116.6 degrees. And this becomes the answer we're looking for. Let's go to the next question. Question number 8. A geometric progression has first term A, common ratio R, and sum to infinity S. A second geometric progression has first term A, common ratio capital R, and sum to infinity 2S. On A, show that R is equal to 2 capital R minus 1. So here we're going to use the information given. And since we're talking about sum to infinity, we know that the formula for sum to infinity is A over 1 minus R. That's when A is the first term and R is the common ratio. Now from the question here, they say a geometric progression has first term A, common ratio R, and sum to infinity S. So therefore S should come out as A over 1 minus R. And they also say that a second geometric progression has first term A, common ratio capital R, and sum to infinity 2s, which we can say 2s is equal to a over 1 minus capital R. So we now have these two equations. So they want us to show that R is equal to 2R minus 1. So here I'm just gonna substitute the first equation here into the second equation, which means that in place of s in the second equation, I will put a over 1 minus r. So therefore, equation 2 will be like 2s. So in place of s, we have a over 1 minus r is equal to a here over 1 minus capital R. So we can simplify this now to 2 times a, that's 2a over 1 minus r is equal to a over 1 minus capital R. So solving this, we can cross multiply, so we can have 2a multiplied by 1 minus r is equal to a multiplied by 1 minus r. Then expanding the brackets, we have 2a minus 2ar is equal to a minus ar. Now you can see that the a is common for all the terms, so we can divide both sides by a. So we're left with 2 minus 2r is equal to, here we get 1 minus r. Now we want to make r the subject, so I am going to take minus r to the left side, so it's now r, and I'll take minus 2r and 2 to the right side. So minus 2r becomes positive 2r, 2 becomes minus 2, but we have the 1 here already, so that's plus 1. So we can now just simplify this to r is equal to 2r, and minus 2 plus 1 is minus 1, so r comes out as 2r minus 1. And that's what they want us to show. So let's move on to part B. It is now given that the third term of the first progression is equal to the second term of the second progression. So on B, express S in terms of A. Here they're saying that the third term of first progression is equal to the second term of second progression. So for the third term of the first progression, we are going to use the general term for an AP, which is AR to the power n minus 1. So we are going to be saying that's A, the first term, and R to the power of 2. And it's equal to the second term of the second progression. For the second progression, that will be A times R, which is capital R to the power of 2 minus 1, which is just 1. So from here, we are going to use the substitution because we had obtained in part A that R is 2 capital R minus 1. So in place of R here, we'll be having A of 2R minus 1 squared is equal to AR. And I think you can see that A is appearing in both sides, so we can divide both sides by A. So we're just left with 2R minus 1 squared, which I can now expand to give us 4R squared minus 4R plus 1, and that's going to be equal to R. And I can subtract R from both sides, so 4R squared, subtracting R from both sides, we get minus 5R, and that's plus 1 is equal to 0. And now we have this quadratic equation, so I can factorize. So 4R squared, I'm going to split it into 4R and R, and factors of 1, I'll put a 1 here and a 1 here. And in order for us to get minus 5R, after multiplying this 2 and adding them to this 2, it means that I should be having a minus here and a minus here. So we've now factorized it, which therefore means that either 4r minus 1 is equal to 0 or r minus 1 is equal to 0. Here we get r coming out as a quarter, and here we get r coming out as a 1. So the value of r, which is the common ratio for the second geometric progression that we want, should be a quarter. So therefore, the value of r we want is a quarter. So right now, I can now take the expression for sum to infinity for the second geometric progression, and we are going to substitute r into it. So we're saying since 2s is equal to a over 1 minus r, and r is a quarter, it therefore means that 2s is a over 1 minus a quarter. So let's simplify this. So this is going to be 2s is equal to a over 1 minus a quarter is 3 quarters. And this can simplify to 2s is equal to a over 3 quarters is like 4 over 3a. Okay, and we can divide both sides by 2. So if we divide both sides here by 2 and here divided by 2, then the 2's here will cancel to get 2. So we get s here coming out as 2/3 of a eventually. So this becomes the value of s. And that's how we do it with this question here. Question number 9. The diagram shows a circle with center A passing through the point B. A second circle has center B and passes through A. The tangent at B to the first circle intersects the second circle at C and D. The coordinates of A are -1 and 4, and the coordinates of B are 3 and 2. So they say here, find the equation of the tangent CBD. Now, in order for us to find the equation of the tangent, we would need to know what the gradient of the tangent is. So to find this, we are going to find first the gradient of the line AB, because we know that AB, since it's a radius of the first circle, it should be perpendicular to CBD. So let's start with that. So we're saying here that the gradient of AB should be change in y over change in x. So I'll find the difference of the y coordinates. That will be 4 minus 2, and is divided by the difference in the x coordinates, that's -1 and -3. And what does that give us? That will be 4 minus 2, which is 2, over -1 minus 3, that's -4, which is -1/2. So that's the gradient of AB. So now that we have the gradient of AB, we can therefore say the gradient of CBD should be the negative reciprocal of the gradient of AB, since they are perpendicular. So negative reciprocal of -1/2 should just be 2. So we now have the gradient of CBD. Now we can now work out the equation of the tangent. We are going to say y minus y1 is equal to m of x minus x1. So that will be, since we have the point B as 3, 2, y minus 2, that's the y coordinate, is equal to m, which is 2 of x minus 3, which is y minus 2 is equal to 2x minus 6, which is y is equal to 2x minus 6, adding 2 to both sides, that will be plus 2. So eventually we have the equation coming out as y is equal to 2x is -6 plus 2, which is -4. And that's the answer right here to part A. That's the equation of the tangent CBD. Let's go down to part B. Find an equation of the circle with center B. So let's go back to the diagram. Now we want to find the equation of this circle. So the center here is known, that's B, but now what we need is the radius of the circle, which is AB. So to get the radius AB, we need to work out the length of the line AB, and we are going to use the coordinates of A and B to work out the length of the line. So this is the data that we will need. So we're going to work out the radius R. AB squared is equal to, and that's the x coordinates, that's -1 -3 squared, plus the y coordinates 4 -2 squared, and this will give us -4 squared, and that's plus 4 -2, that's 2 squared, so that's 16 plus 4, so AB squared comes out as a 20. So we now know what the radius squared is, which is 20, and the coordinates of the center of the circle is B. So we're going to use the point B as the center. So we are now saying the equation of the circle will now come out as x minus the x coordinate, which is 3 squared, plus y minus the y coordinate, which is 2 squared, and it has to be equal to the radius squared, which is AB squared, and that's 20. So the answer we get here is this. And that's how we do it for part B. Part C, find by calculation the x coordinates of C and D. So let's go back to the diagram. Now you can see that the points C and D intersect the circle here and here, and we'd already obtained the equation of the line CBD. So we will only need to find the points of intersection of the circle and the line CBD. The equation of the line CBD, we got it to be y is equal to 2x minus 4. So here we've got y is equal to 2x minus 4. And we also have the equation of the circle center B. We got it to be this, x minus 3 squared plus y minus 2 squared is equal to 20. So that's x minus 3 squared plus y minus 2 squared is equal to 20. So to get the points of intersection, which will give us the coordinates of C and D, I will have to work these two equations simultaneously. So I'll substitute the first equation into the second equation. So this will be now x minus 3 squared plus y, but in place of y, I'm going to put 2x minus 4. So it will be 2x minus 4, then minus 2 squared is equal to 20. So let's simplify. So that's x minus 3 squared plus 2x, and minus 4 minus 2 is minus 6 squared equal to 20. Expanding the brackets here, I get x squared minus 6x plus 9. And expanding the brackets here, we get 4x squared minus 24x plus 36. And that's equal to 20. Now for the like terms, we have x squared and 4x squared. So that's 5x squared. And minus 6x minus 24x is minus 30x. And here 9 plus 36 gives us 45. And that's equal to 20. So now we'll be having 5x squared minus 30x. And subtracting 20 from both sides, that's 45 minus 20. And it gives us 25. So it's equal to 0 here. So here I can divide by 5 both sides. So dividing each term by 5, I'll be getting x squared minus 6x. And dividing 25 by 5, I get 5 is equal to 0. And I can factorize here, and I put an x here and an x here. And now for the factors of 5, whose sum is minus 6, I can use minus 5 and minus 1. So this is what we get. So we can therefore say that either x minus 5 is the one that's equal to 0, or x minus 1 is equal to 0, which gives us x coming out as a 5, or x coming out as a 1. So we now have x is equal to 5 and x is equal to 1 as our final answers. Question number 10. The diagram shows a sector CAB, which is part of a circle with center C. A circle with center O and radius R lies within the sector and touches it at D, E, and F, where C or D is a straight line and angle ACD is theta radians. So in A, find CD in terms of R and sine theta. So here CD is this line here. And in order for us to find the length of this line, let us first see if we can work out the length of the line OC. Now OC is part of this triangle here. And this triangle is a right angle triangle since the line CFA is tangent to the circle. Now, using this right angle triangle, we can say sine of the angle theta is equal to the opposite side here will be R over the hypotenuse, which is OC, which therefore means we can work out for OC to come out as R over sine theta. Now, if OC is equal to R over sine theta, we can now say CD is equal to the length of OC plus the length of OD, of which OD is also a radius to the circle equal to OF. So CD should just be equal to OC, which is R over sine theta, plus OD, which is R. And that's the answer right here for part A. Part B. It is now given that R is equal to 4 and theta is equal to a 6th pi. So on B, find the perimeter of sector CAB in terms of pi. So let's take the diagram here and let's place it right here. So right now, they want us to find the perimeter of the sector CAB. So by perimeter, we're talking about CA plus this line CB, and we also have the arc AB down here. So this gives the perimeter of the sector CAB. Now, I think you can note that CA and CB should be equal to CD because they are all like radii for the sector. So we're saying here CA is equal to CB and all these are equal to CD. And in part A, we had worked out an expression for CD and we got it as R over sine theta plus R. So this is all equal to R over sine theta plus R. Now we've been given that R is equal to 4 and theta is equal to a 6th pi. So this will be equal to 4 over sine theta, which is sine of a 6th pi, and that's plus R, which is 4. Now sine of a 6th pi is a half. So it's more like we have 4 over a half plus 4. And 4 divided by a half is 8, and 8 plus 4 is 12. So we have right here CA and CB being equal to 12. Now what remains is for us now to find the length of the arc AB. Now for the length of the arc AB, we can say the radius of the sector, which is CA, which we got to be 12, times theta, which is this whole angle here, which happens to be 2 theta. So that will be 2 of theta, and theta is a 6th pi, so we have a 6th pi here. So for the arc AB, we can say that's 12 times, getting 2 into 6, that's 3, so that's a 3rd pi, or pi over 3. So it's 12 times pi over 3, and this comes out as 4 pi. So therefore, the perimeter of sector CAB should come out as, adding CA and CB, that's 12 plus 12, and arc AB, that's 4 pi. So we should get the answer as 24 plus 4 pi. And that's how we do it. Let's go to part C. Find the area of the shaded region in terms of pi and root 3. So here is the diagram. So what we're looking for here is the area of the shaded region. Now, in order for us to find the area, let us consider this triangle right here. That's triangle FOC. Now, if we can work out the shaded region under the triangle FOC, then we can always multiply it by 2 to get the total shaded area. So what we need to do first here is to calculate the area of triangle FOC. And for the area of triangle FOC, we can say half times the base times the height. So that would be half times the base, which is FO, times the perpendicular height, which is FC. So this is equal to half times FO, which is equal to R, and that's times FC. Now for FC, FC is an adjacent side to this right angle triangle. So to find FC, we would say the hypotenuse OC times cosine of the angle theta. So that's half times FO is R, and OC, we'd worked out OC in part A in terms of R and sine theta as R over sine theta. So we have here R over sine theta, and then times this cos theta here. So this is half times, we've been told that R is 4 and theta is a 6th pi. So R is 4 here, times another R over sine theta, which is sine of a 6th pi, which is a half. And then that's times cos theta, which is cos of a 6th pi, which is root 3 over 2. So we can now simplify this to give us half times 4 times 4 divided by a half is 8, and then that's times root 3 over 2. And finally, we can say half times 4 is 2, and 2 times 8 is 16, and 2 into 16 gives us 8, so we get 8 root 3 for the area of FOC. So now that we have the area of FOC, we now need to work out the area of the small sector here. Now for the area of this sector, we can say area of the sector is equal to half times R squared, which is just R squared, times theta, which is this angle here, which is a third angle to the right angle triangle. So that's pi over 2 minus theta. So this is going to be half times R squared. R is 4, so that's 4 squared times pi over 2 minus theta, which is a 6th pi, or pi over 6. So we can simplify this. So it's half times 4 squared, which is 16. So half of 16 is 8. And pi over 2 minus pi over 6, we get pi over 3. So the area of this small sector should come out as 8 pi over 3. So we can now say for the area here, which I want to call A1, and let's call this A2. So for the area A1, we're going to say it's area of the triangle FOC minus the area of the small sector here. And that's area of FOC is 8 root 3 minus area of the sector is 8 pi over 3. And therefore, to find the total area, total shaded area, it is going to be twice A1 or A1 plus A2. So it is going to be 2 times what we got here. So it's 2 of 8 root 3 minus 8 pi over 3. So this is going to give us 16 root 3 minus, multiplying 2 times this, we get minus 16 pi over 3. And this here is the answer to part C. Question number 11. The functions f and g are defined by f of x is equal to x squared plus 3 for x is greater than 0, and g of x is equal to 2x plus 1 for x is greater than minus a half. So on A, they say find an expression for f of g of x. So we're saying here, when we have f of g of x, it means that g of x is an input into the function f. Now the function f is such that f of x is equal to x squared plus 3. So in place of x, we have g of x. So it will be g of x squared plus 3. So this therefore means that f of g of x should be equal to g of x, which is 2x plus 1 squared plus 3. So this right here is the expression for fg of x. We might also need to know what the domain of f of g of x is. Now, since we're saying g of x is an input into f, and f is restricted for the domain x is greater than 0, so it also means that g of x should be greater than 0, which therefore means that g of x, which is 2x plus 1, should be greater than 0. And solving this inequality, we get x being greater than minus a half. So the domain of f of g of x is x is greater than minus a half. Let's go to part B. Find an expression for fg inverse of x and state the domain of fg inverse. So here we're going to say let f of g of x be equal to y, which therefore means y is equal to f of g of x, which we got to be 2x plus 1 squared plus 3. So from here, we're going to make x the subject. So this is going to be 2x plus 1 squared is equal to, subtracting y from both sides, that will be y minus 3. And from here, if I square root both sides, then it means I'll be having 2x plus 1 is equal to plus or minus the square root of y minus 3. Now, if I want to remain with x here, I will subtract 1 from both sides and divide both sides by 2. So I'll be having x is equal to minus 1 plus or minus the square root of y minus 3, all divided by 2. So we've made x the subject right here. Now, I would want you to notice that the function fg is restricted for the domain which is to the right of the axis of symmetry, which is x is greater than minus a half. Now, this means that we are going to take x is equal to minus 1 plus square root of y minus 3 all over 2 for that reason, since x should be greater than minus a half. Now we can interchange the variables, so that will be y is equal to minus 1 plus square root of x minus 3 all over 2, which therefore means fg inverse of x should come out as minus 1 plus the square root of x minus 3 divided by 2. So this here is the expression for fg inverse. Now they say state the domain of fg inverse. Now you need to understand that the domain of the inverse function is equal to the range of the function. Now if you consider the graph of the function fg, you find that it's a parabola with a minimum point at minus half and 3. And the range of the function fg is f of g of x is greater than 3. Now, since the range of the function is equal to the domain of the inverse, we can also say that the domain for this inverse is x is greater than 3. And that's how we find the domain of the inverse function. Part C. Solve the equation f of g of x minus 3 is equal to g of f of x. So here, the first thing that we can do is to first find g of f of x. Since f of g of x, we already have it. So for g of f of x, if you look at our functions, so I'll just place them here. So when we say g of f of x, we're saying that we're inputting f of x into g. That will be 2 of f of x plus 1, which is 2 of x squared plus 3 plus 1. So that's g of f of x. So when we say f of g of x minus 3 is equal to g of f of x, we're saying f of g of x, we got it to be 2x plus 1 squared plus 3. So that's 2x plus 1 squared plus 3. And that's going to be minus this 3 is equal to g of f of x, which is 2 of x squared plus 3 plus 1. Now 3 minus 3 gives us 0. And expanding this bracket, we get 4x squared plus 4x plus 1 is equal to, expanding here, we get 2x squared plus 6 plus 1. Now, taking all the terms to one side, we have 4x squared subtracting 2x squared to get 2x squared. And we have the 4x here. And we have 6 plus 1, that's 7. And 1 minus 7 is minus 6. So everything is now equal to 0. So we can factor out 2 here, and we get x squared plus 2x minus 3 equal to 0. Factorizing, we get x here and x here, and factors of minus 3, whose sum will give us 2. We have plus 3 and minus 1, which therefore means either x plus 3 is going to be equal to 0, or x minus 1 is equal to 0. Here we'll get x coming out as minus 3, and here we'll get x coming out as 1. But since our functions are defined for values of x that are greater than minus a half, we can therefore take x to be equal to 1. So the solution to this equation is x is equal to 1. Question number 12. The diagram shows a curve with the equation y is equal to 4x to the power of half minus 2x for x is greater than or equal to 0. and a straight line with equation y is equal to 3 minus x. The curve crosses the x-axis at A with coordinates 4, 0 and crosses the straight line at B and C. So on A, find by calculation the x-coordinates of B and C. So right here, the points B and C are the points of intersection of the line and the curve. The line has equation y is equal to 3 minus x, and the curve has equation y is equal to 4x to the power of a half minus 2x. So we're going to solve this equation to find the values of x. What I'm going to do right now is I'm going to take minus 2x to the left side by adding 2x to both sides. So if I do so, I'm left with 4x to the power of a half on the right side, and on the left side we'll be having 3 minus x plus 2x, which is 3 plus x. And from here I'll square both sides, and by doing so I have 3 plus x squared, which is 9 plus 6x plus x squared, and that's equal to 4x to the power of half squared is 16x. Now I'll have 16x come over to the left side. On the left side I have x squared already, and 6x here minus 16x gives us minus 10x, and it's plus 9, the 9 that we have already. So that's all equal to 0. So from here I'll factorize. I'll have x here and x here, and factors of 9 whose sum will give me minus 10 should be minus 9 and minus 1, which therefore means that either x minus 9 is equal to 0 or x minus 1 is equal to 0, and therefore we get the value of x coming out as 9, and here the x value comes out as 1. So the x coordinates of B and C are x is equal to 9 and x is equal to 1, and that's the answer to part A. Let's go to part B. Show that B is a stationary point on the curve. Now we have this point B on the curve, so we want to prove that it's a stationary point. The equation of the curve is y is equal to 4x to the half minus 2x. So we have the equation y is equal to 4x to the power of a half minus 2x. Therefore, dy by dx, differentiating, we are going to get the half coming down to where 4 is. So that will be 4 of a half, and that will be x to the power of a half minus 1, which is x to the power of minus a half. And differentiating minus 2x, we get minus 2. So this can be simplified to 4 times a half, that's 2, so that's 2x to the power of minus a half minus 2. So that's dy by dx here. Now if B is a stationary point, then it means dy by dx should be equal to 0. So therefore we can say 2x to the power of minus a half minus 2 is equal to 0, and let's solve for x. So we add 2 to both sides and divide both sides by 2, which means we have x power minus a half is equal to 1. And this translates to x coming out as 1. So x is equal to 1 when dy by dx is equal to 0, and this confirms that the point B is a stationary point, since on part A we'd obtained the coordinate of B to be 1, and B here is said to be a stationary point. So hence shown. Let's go to part C. Find the area of the shaded region. So we need the area of the shaded region, and I'm going to take this diagram here, and here it is. Now to get the shaded area, we are going to need to find the area between the line and the x-axis from this point here up to the point which is the x-coordinate of C. Now the x-coordinate of C, we got it to be 9, so we got 9 here. And after we've found the area of this triangle, we can now find the area under the curve from this point here all the way up to 9 and subtract it from the area of the triangle. So let's start with area under the triangle. Now for the area of the triangle, we can use the formula half times the base times the height of the triangle. So it's half times, we're going to use this as the base of the triangle. So it's from this point here. Since it's on the x-axis, we can set y to 0 and say 0 is equal to 3 minus x. So the x-coordinate here should come out as a 3. So we have a 3 here. So the length of the base here will be 9 minus 3. So that's 6. And that's multiplied by the height of the triangle corresponds to the y-coordinate of C, which we can read on the y-axis. Now for the y-coordinate of C, from the line y is equal to 3 minus x. The x-coordinate is 9, so y should be 3 minus 9, and therefore y is minus 6. So the height of the triangle is 6. So this gives us the area under the triangle to be half times 6, that's 3, and 3 times 6, that's 18. Now we can work out the area under the curve. So this is the area from the point A to the point with coordinate 9. So we integrate from 4 to 9. The function 4x to the power of a half minus 2x dx. So what will we get? Differentiating 4x to the power of a half, we get 4x to the power of a half plus 1, that's 3 over 2, all divided by 3 over 2, and that's minus, and differentiating this we get minus 2x to the power of 2 over 2, and that's from 4 to 9. Let's just simplify this. 4 divided by 3 over 2 is 8 over 3, and that's x to the power of 3 over 2. And that's minus, cancelling this 2, we get minus x squared, and that's from 4 up to 9. I can now substitute 9 into this, so that's 8 over 3 of 9 to the power of 3 over 2. That simplifies to 27, and that's minus, substituting 9 into x squared, that's minus 9 squared, which is 81. And we subtract substitution of 4 into this. So 8 over 3 of 4 to the power of 3 over 2. Now 4 to the power of 3 over 2 is 8. So 8 over 3 times 8 is 64 over 3. And that's minus, substituting 4 into minus x squared, we get minus 16. So we can now simplify this whole thing. And now I divide 3 into 27, that's 9, and 9 times 8. We get 72, and that's minus 81, and that's minus 64 over 3, and that's plus 16. So we can just calculate this. So that's 72 minus 81 minus 64 over 3 plus 16. And this gives us minus 14 and a third. So we have minus 14 and a third. That's the area under the curve. So we're now saying for the shaded region, area of the shaded region, it's going to come out as area under the triangle, which is 18, minus area under the curve. We're going to take the positive value for the area. So that's minus 14 and a third. And the final answer comes out as 3 2/3. And that's how we work out the area of the shaded region.